Thanks. Hey guys, it's really exciting to be here. Thanks a lot for the invitation. My name is Tomek Wiszniewski. Wait, this is super loud. Better now? Better now? Okay. My name is Tomek Wiszniewski. I'm the Tomek WI on Twitter and Tomek WI everywhere else. And I work at an amazing company called Listable, based in London and San Francisco. And this talk is about microservices on the front end. The most important thing I want you to take away from this talk is that they are a lifesaver for bigger teams, and I really mean it. But if you're working in a smaller team, there are also some really cool stuff which such an approach enables. But you need to be a little bit more careful in that setup. Now, one more thing before we start. I think this stuff is huge, and I'd really love you to get the most out of this talk. So if you find yourself drifting away, don't hesitate to interrupt me. I really love questions, so do ask, and don't wait for the end. Okay, let's start with a quick poll, just to know where we are. Who of you guys has heard of web components? Okay, that's quite a bunch. Don't put your hands down, keep them in the air, please. Yeah, and now put your hand down if you've heard bad stuff about web components. So if you've heard bad stuff about web components, put your hands down. If you haven't, keep them in the air. Okay, cool. There are a couple of courageous people, 4 or 5, who haven't heard. Thanks a lot. That was amazing. You can put your hands down now. But basically, almost everyone who has heard about web components has heard lots of bad stuff about them. For those, just so everyone is on the same page, web components are basically, it's a little bit like a subset of React, but built right into web specifications, which means it lives directly in the browser and allows some of the cool stuff that React allows us, but with zero overhead, with running fully on native code. But since web components are so amazing, how come they have such a bad reputation? Almost all of us who've heard about them have heard lots of bad stuff about them. And now, to understand this a little bit better, I prepared a little game for you. It's a role-playing game. So imagine, using your imagination, just imagine you wake up in a posh mansion, in a castle or something, and all you know, there are two cups of tea on the table in front of you, and all you know is you need to deliver these 2 cups of tea to the owner of this mansion, to some sort of king or I don't know, prince. So you stand up, pick up those 2 cups of tea. So let's all stand up, pick up 2 cups of tea. Yeah, come on, go ahead. I mean it. Yeah, I've got an easier situation because I actually have 2 things in my hands. But you just imagine you're holding 2 cups of tea, and now you're going along to this master of the house, and suddenly you have this crazy itch here in your elbow, like, I don't know, a mosquito sting or a bee sting or something, and you just have to scratch it. But you're holding 2 cups of tea. And what do? I don't know. I'll try.
I have a question.
Yeah.
Is it still tech talk?
Sorry?
Is it still technology?
Yeah, absolutely.
Okay.
Absolutely. That's just a little game to keep our minds fresh. Okay, thanks a lot. If anyone has tried this, amazing. I've tried this many times before this talk, and I can tell you it's really hard to scratch your elbow while you're holding things in your hands. Most people use their nose, but as we all know,
I would be holding 1 cup in my hand, and I would put the second one here. I tried that.
Really?
It works.
Yeah, that's an acrobat then. I wouldn't manage that.
With JavaScript and CSS.
Yeah, and that's where it becomes tech related, because basically that's what happened with web components as well. Wait, that's what I mean. Yeah, so basically web components are the nose of web development, because they came in a time where there were no real tools for encapsulating things, for building big complex web applications. And people had great expectations of them. So basically it was a time of jQuery and Angular, but people thought they can build crazy big web applications with those web components. And disappointment, because web components are not made for that. There are much better tools for this stuff, just like you can scratch things with your nails a lot better than with your nose. We've got React and a couple of other frameworks which allow us to build complex applications with scaling up very nicely without all those issues that anyone who's been in the industry for more than like 3 or 4 years has been fighting with. But there comes a question, because basically a nose is also a very useful body part for sniffing stuff. I don't know. I guess life would be pretty dangerous without a nose. So I'm pretty sure web components are also useful for something. And now there's a question. I'd like you to have a go and try and guess what it is. What is it that web components are really good at? And sort of
Encapsulation.
Encapsulation, yeah, that's sort of half of the story. Yeah?
They're native.
They're native, yeah. But what is the sort of, because these are assets, but I want to hear about the goal. What are they good for doing?
Reusable.
Reusable, that's also an asset.
Compatible.
Compatible, that's also a great asset. All these build up to one thing. The title of the talk might be a little bit a bit of a hint. Microservices on the front end. Yeah, exactly, man. That's that's crazy. I've been thinking about this for like, I don't know.
Can you explain? Because
yeah,
I
absolutely.
said now you explain.
Absolutely. That's basically let's the best explanation is just looking at some real stuff, at some real world code. So that's what we'll do. We'll look at a web app I made using this technique, microservices on the front end. Can you still hear me this way?
Yeah.
Okay, that's nice. And then we'll have a look at a closer look at those tiny bits that make up this app and sort of weigh the drawbacks and the trade-offs and everything, so we know what we're actually dealing with. So let's start with a bit of a story again. Yeah, this is a slide you could tweet if we had internet here, but you can take photos and tweet later, or just sort of memorize this. This is the one thing I want you to take away from this talk. Web components are microservices for the front end. Now, before this talk, I've been looking for a presentation timer to help me keep on track, and I couldn't find one. So I built one myself. There it is, ticking away nicely. And this was also a great use case for testing. For showing you these concepts in a nice and self-contained way. So this is the little web app which helps me keep on track. We can pick which color we start with, and then we can pick breakpoints for the talk, so I know where I should be by now. So in this case, we start with a pink background. Then in the 3rd minute, we change that to black. Then we can change that in the 10th minute to blue. I don't know, red at the end. After 20 minutes, let's say we're screwed, and we're ready to roll. There it is, ticking away nicely. And now let's look under the hood, because this is what's really interesting about this stuff. This is built using web components in such a way as you use microservices on the backend. So these are basically a couple of smaller web applications stitched together with a sort of glue layer, with like a network layer in the backend world of microservices. So there we go. We have the timer display, which is a React application. You can see that by what's happening in here. And the interesting thing is how we can communicate with this stuff. So we can add an attribute and say it's paused, and there we go. It's paused. It's not ticking anymore. Now when we get rid of this attribute, it's ticking away again. We can change the color this way, and this is basically you interact with it like with any other element in the DOM.
What
But
if
there's
you
also
copy HTML of this and paste HTML as sibling of this?
yeah, we can try this. Copy
As
HTML.
copy as HTML. It's
Auto
outside
HTML,
copy.
yeah. And now we can try and paste this next to it, like for example let's try it in a smaller element. Let's pause this one and try to find something smaller, like here in the control panel. I don't know. Let's try it inside this H2. So I guess we'll probably need this to be a position relative. So let's do it right now to make sure we're doing the right thing. And now edit HTML, and instead of here's how it goes, let's paste that stuff. And it's not.
Go outside.
Yeah, I think I've.
Click it.
Yeah. So there we go. It's now ticking away. So we've now got 2 timer displays. We can say this one is green, red, green, blue. This one is green. We can pause this, and we can play the other one as well. And this is the previous one. So basically, this is pretty straightforward. This is one way we can communicate with this, exactly like with React. So we've got like something like props, which go down into the component, and we can also communicate with the outer world by sending events up. This timer display is a pretty simple thing. It just takes information from the outside world, like a so-called DOM component. But the other one is a bit more complex, timer controls. There's a lot of stuff happening in here. So basically, it also takes an initial color as a that's not a real color, as a prop. But it also sends events to us. So we can say we want to listen to an event called color breakpoints, and this is an event which goes off whenever we change this stuff. So there you go. I've just added a color breakpoint, and we can see there are now not 3 breakpoints like there were before, but 4 of them. We can add one more, and there we go, 5 of them. We can change the color in the last one. It's now AA00. We can change it to black. And there we go. It's black in the last one. Yeah. So this was a quick overview of how data flows downstream, how data flows upstream, and we'll now have a closer look at how they actually interact with each other, and the implications that this brings. So. Yeah, we can start by the next slide. Basically, I think that the biggest benefit that this approach brings to us is just as in the world of backend microservices, you can actually scale a company to a huge size and still like have 1,000 of engineers and still keep a startup spirit in them. So you can still split it up into little teams of 2 or 3 or 4, just like those, I don't know, students hacking away in a garage or a dormitory, and keep the same spirit, the same pace of going forward. Basically, it's just like a living organism. We're all built out of little cells which have very specific responsibilities. Just like plants, yeah, and these cells cooperate with each other and can do amazing stuff like grow into trees, or I don't know. As humans, we're also built out of cells, and we can build React applications and stuff. Yeah, and this we can see this in contrast to what I call mushroom companies, which basically, because I don't know if you know this, I've remembered this from a biology lesson. A mushroom, every single mushroom is one single cell. You can it's got lots of stuff happening inside, but there are no boundaries between the cells. And if we look at the real world, we can see lots of benefits that mushrooms have as well. So mushrooms grow amazingly quickly. Yeah, so we can have just flat ground one evening, and then we go out to the meadow next day, and there's I don't know, huge mushrooms which popped up overnight. Yeah, plants can't grow that fast. But then again, a mushroom can only grow this big. This is a really giant mushroom, and that's it. Yeah, you can't scale a mushroom company as well as a plant company, a tree company. So and let's see how this translates to our world of front-end microservices. This is the project. It's basically a monorepo. I've prepared a little directory where we can see that. There's actually 4 web components playing together to build up this application. One of them is the most complex one, timer controls, the one that we see initially. This is built with Elm inside, and timer display, as I mentioned previously, it's built with React, and we can actually do some cool stuff. For example, we can get into timer controls and preview or mount just this single mini app without the overhead of the other stuff. So there we go. Elm has built it for us, and now there it is. As you can see, there's nothing else other than this Elm app. It works just like it did previously, and this team, which is responsible just for this app, can have their own workflow, can have their own toolset, and can start this mini app with 0 overhead. I don't know. How many of you guys work in companies which have more than 10 engineers? That's a lot. So you probably know this feeling of starting your project and then waiting like 3 minutes, 4 minutes, 10 minutes till it finally builds. Then you start implementing a feature. You hit save, and you expect your changes to be there, right, ready for testing, but they're not there. You still have to wait 2 more minutes or 15 seconds. Even 15 seconds feels like ages in a fast-moving environment. So in such a setup, you can have really teams of 2, 3, 4 people working on a very small, self-contained part of the application, and keep it moving as fast as little startups move. Yeah, let's move on. Or actually, no. There's one more thing I wanted to show you how this is all glued together. I actually chose to let's go one step backwards. I chose to build the app shell, which is the app shell is what glues together all these components, web components playing together. And where is it? I think it's in public. Yeah, there we go. There's our shell.js. It's not easy to type in here. Where's Atom? There you go. It's actually built with pure JavaScript, and you can see it's basically, because the top of this file that you can see here, this is just setting
the initial color, which is random, and wiring up custom elements is just 10 lines of code or something. It's just, we set an attribute of, in this case, it's timer controls, so the sort of heart of the application. And we say, whenever the initial color event fires, we set the initial color, which is defined here. Yeah, so set initial color means do some stuff inside the app shell. This is just pure JavaScript imperative ES5 boring code. But this is where the magic happens. So basically, one component sends up an event, and the boring ES5 app shell listens to this event and routes the value where it should go. Right. So this is how tree companies work and mushroom companies work. But now the next big thing about web components, which might also be a huge gain for some businesses, is the ability to ship just part of the app independently. So I don't know. Perhaps you know this situation as well, where you've got a client demo looming over you. You've got like 3 hours to a big demonstration at Netflix or Airbnb, and you've got to ship stuff really quickly, and you find out afterwards you've got like a week's worth of fixing bugs because this rush broke the app for that client. It broke some workflow for another client. It broke, I don't know, authentication where no one can log into the app. This is much nicer in the world of microservices, where you can actually deploy. In the case of our little counter, you can deploy the counter independently. If you've got a really important demo for someone who needs not colors, but I don't know, buzzing or sounds or anything else. Nice. The next big win is the whole mindset of developing web components, where you actually have you actually need to think about how things go wrong. Because when developing a monolithic application where everything lives in the same code base, some scenarios are really difficult to reproduce. Some bugs are really difficult to reproduce because the series of events which leads to that weird state is very long and convoluted, and you basically end up just not thinking about it because it's like such a very marginal situation. When developing web components, you're living in a world where you don't have a clue about what's living on the outside of your web component. So all you know is whenever someone sets the props to specific values, everything must just work. So you end up writing end-to-end tests for a single web component, which run crazy fast and are very, very robust in the end, because you need to think of all those edge case scenarios. One more big win for teams of any size actually is the ways in which you can use tools. So as we saw in our previous in the demo of the timer, we used Elm for one part of the application where we had complex interactions and lots of things which could theoretically go wrong. And then we also had some parts of the app in pure vanilla bare metal JavaScript. We had some parts of the app in React. This might be a problem in some situations, but this also, in terms of maintenance, but this is also a tremendous. For me, it's a very freeing thought, if you know what I mean. When setting up a project, because apart from working at Listable, I'm also working on a small side project which might turn into a startup someday, and it was a pretty big headache because I love Elm, but I was a bit scared of whether it's a good choice for building a whole company on top of it, because it's young and perhaps the community
it's growing like mad these days, but perhaps it starts shrinking someday, and the technology dies away. This is no longer a problem with web components, with microservices, front microservices, web components, call them as we wish. Because if it turns out that the Elm starts dying away, we can just sort of keep the existing code base that we have in Elm, even if it's monolithic, and start just whenever we work on a new feature or need to refactor an existing feature, we just sort of slice it down, cut away a chunk of the Elm code base, and write this chunk sort of behind this API. Write this chunk in the next big thing coming after Elm and React. Cool. Is the pace okay for you? Are you following along? That's cool. One last thing, which I think is really good with web components, is that you end up thinking about performance a lot more. It's basically web components are basically performant by default. And let's if you don't just screw things up. I've actually used to build this quickly. I've used Polymer, which is known to be huge and chunky. But even so, let's see how the whole thing behaves if we are on a very bad network. Like this is a mobile thing, and wait, I need to make it a little bit smaller. And let's throttle the network, so it's like we're on pretty crappy. We're on a pretty crappy 2G connection. And now let's empty the cache and hard reload, and let's see what happens. So basically, in an instant, even though the app is pretty fat and bulky, we see something which is way better than a static preloader. So basically, part of the app, which is hidden inside the app shell, is already there and working. Now, if we're a little bit patient, we can wait for all the other stuff streaming in. We can read the manual while we wait for that stuff, and boom, something came in. This is another web component, and this is the Elm code base. As you can see, the Polymer elements are not there yet. They weren't there a moment ago. But even though they were not there, I can assure you we could use the application just as well. We could click the Ready to Roll button and use the application, even though it hasn't all come streamed in yet. So, and this is a side effect of thinking about those little modules in a very isolated way. So even if other components around are not available, I still need to be robust enough to work. Yeah? Cool.
I have a question. If you could go back to this
Yep.
timeline. Okay, so what makes this app actually over 1 megabyte?
Excuse me?
Because I appreciate this progressive web app performance, but still, why it's over 1 megabyte? Like the entire application.
You mean why are there so many requests? Yeah, going.
No, why it's way
Can you sort by
1.1
size?
megabyte?
Yeah, absolutely. The main reason there's such a large delay is the latency. As you can see, we're throttling.
No, but now I'm only about the size of the app. So
okay.
at the bottom you could see 66 requests and 1.1 megabyte transfers.
Yep. This is not much for a modern web app. If you know
It's,
other. But to be honest, I did take lots of shortcuts to get this up and running as quickly as possible for this talk, and I didn't build these components by myself, but I used Polymer, which is big and chunky and clunky, because it's just web very easy to use regardless of the technology you're using. But the other big thing is this app is if you visit this. Wait, where is this? This is the whole app. If you visit present.now.sh, it's served from an amazing service called now.sh, which supports HTTP2. So I guess there are 66 requests going on, but they can all there's only one handshake with the server, which needs to be done to start streaming those in. So if you're on a normal
normal connection, they all stream down in parallel, and the app is there for you all in a moment, all of a sudden. Cool. That was a very good question. And by now, I guess there were lots of amazing things which I showed you. And if I were you, I'd be a bit suspicious, because every time something sounds so amazing, there are surely some trade-offs which the guy isn't talking about. So if I may ask you, who of you have doubts that this sounds suspicious? It's too good to be true. Okay. Yeah. Cool. I'm doing really well then, if you're not having doubts. But four people, 6, 7 people have doubts by now. Okay, and now I'll try and look at the lowdown and see if the things that I explain address the doubts that you're having, because most of those concerns are probably totally valid concerns. And as I mentioned at the beginning of the talk, this is not for everyone. So the first thing which I already mentioned in the beginning is that this approach of sort of building your team in an organic way out of a big company, out of little startups, it's good for big companies. As it is with a plant, they are tremendously complex organisms. There are individual cells which are super simple, but then there's loads of stuff happening in between the cells. Communication. I've even heard they have something like a nervous system, plants, and that they even have the ability to talk to each other over a distance. This is crazy stuff. But it's the same situation with microservices, whether on the front end or on the back end. In order to get this going, you need to invest a whole lot more in infrastructure and communication between the teams and between the individual components. Cool. Therefore, it's not always good for smaller teams. Usually, it's not what you want when starting a startup. How many of you still have doubts now that I haven't addressed? Cool. No one. Then let's. I still have 3 or 4 things which I wanted to mention, where it's not always the thing which you want.
I have one question.
Yeah.
So actually, the microservices in a backend, they are so they solve a lot of problems, but they causes another problems. Yeah.
Mm-hmm.
So how about this approach in the front end? So you showed some cases, so some problems which can be solved in this approach, but what are the problems which may be caused by this approach?
Yeah. So the question was looking at the web components, at microservices on the back end. They solve a lot of problems, but they also cause other problems which we have to deal with in the end. And that's exactly what I'd like to address now in this part of the talk.
Okay.
I've started by telling that this is not something which smaller teams should immediately go for. And there are 3 or 4 more things which I wanted to make sure you know before you get excited about this stuff. Cool. So to put this simply, a monolith is complex because there's lots of stuff going on in a single code base, and in an ecosystem of microservices, the complexity is still there, but it's just moved to the infrastructure. And sometimes this is what you want. In larger companies, at Listable, we're now scaling the team pretty rapidly, and this turns out to be a very this is probably what we'll go for. This is at least what we're going for on the sort of team structure side, making little microservices on the back end and on the front end as well. Now, yeah, you don't normally want to start with this. This was the second thing I wanted to tell you, and the third thing is just as it's probably more severe on the front end than it is on the back end, because on the front end you want consistency.
You want a button to look the same in wherever a button is used, yeah, in your app. And if you looked closely at early versions of Spotify, Spotify is one of the companies which have been doing this since for a very long time now. You could sense that it doesn't feel like a single app. It feels like sort of windows stitched together of different apps, which have even sometimes different fonts, different font sizes. I don't know. I don't have a screenshot right now because the internet is dead. But you can Google early versions of Spotify and you'll notice this. And I think, and this is something which worked for us at a previous team where I also used this approach. We basically ended up building a style guide, which was very, so to speak, low tech. Most style guides that we build nowadays are built with top-notch technology. React, the React ones are especially nice and immersive and expressive. But there is a if you use top-notch technology for your style guide, you're risking locking yourself into it, because React by itself is I don't know. I guess it's 60 kilobytes gzipped, but not only the download but also parsing this takes a non-trivial time. And if you're building an app, I don't know, in Angular and TypeScript, for example, or in Elm, you're already pulling down lots of frameworky stuff to get your app going, and you wouldn't want to pull in 3 or 4 frameworks just to get your buttons working as you want. So if you pick microservices as your approach for building the front end, you would normally want to build a low-tech style guide, which is built mainly out of CSS classes. You can build tremendous stuff using just CSS, but this is probably the safest approach. Some people also use custom elements, which is a part of the web component specification, as sort of for things which you can't accomplish with just CSS. But then again, using custom elements without any framework is there's a lot of overhead that you need to deal with. It's just not nice. Cool. I think that was it for the drawbacks that I've addressed. I wanted to address. Are there any more questions about like suspicions people have whether this is really as good as it sounds? Because I really want you to leave this place with a firm grasp of why to do this, where to do this, and where not to do this. Yeah, I think the guy in the back was.
I'm curious about the glue that you used to stitch the. So the
Hello?
Oh yeah, no.
Yeah.
It's okay.
No, the stage. So the glue that you said so you said we have these web components which are like microservices, and we need to glue this stuff together. So in this simple example, you've used just plain JavaScript. Yes, pipe style. Like in bigger applications, what do you use? Like, do you use some kind of a framework or architecture style, or anything specific? Because that's interesting to me.
Yeah, this is a very good question. To be totally open and honest, it is an approach that we're just going to introduce to our code base and try out if it works.
But people already did similar things, because before web components came into the game, people simply used iframes to isolate some parts, and iframes also have such mechanism, which is called they can send post messages between frames. So we can do the same thing, but you will limit it to the shape of that frame, because it was always a rectangle. And currently you can go one step ahead. You can style further. And,
yeah, absolutely.
And as long as you stick to events, messages, something which provides you a well-defined contract, and it's something which is being put to, I don't know, strings or simple objects, it should work. Yeah.
So it's just like something like an event bus, which components are listening to and posting to. Yeah, that's
That's all.
Like-
Yeah. iframes use post message mechanism. Yeah. So you can do a very similar thing. In fact, some companies do, and they even provide such frameworks to. For example, in our company, there are some projects which are developed. The backend and the frontend are being developed just together. Yeah? The people simply say what kind of messages they send to the shell app, yeah, and what kind of messages they accept, and how do they react on that. And that should work. Yeah. So, like Tomek says, I would rather say that it's going to be simply the next step.
Yeah, absolutely. That was a very good comment about. Yeah, as far as I know, Spotify is a company which has been using this for 4 or 5 years now. Well, at least since they were very little and just starting out, and they've been using iframes for this stuff. As far as I know, we've also been using iframes at Listable for this stuff so far. But the problem we've had with iframes is the overhead that they introduce. You basically have a browser embedded in a browser, which also in our case meant downloading the whole app twice. All of the React framework needed to be downloaded twice. Most of the code shared between the apps needed to be downloaded twice, and this is just not the experience that we and our users are after. We want this to be a lot more snappy. But this is basically, as you say, this is the next step after.
Yeah, iframes have many drawbacks. It's not like it's a silver bullet. Yeah, this is why also web components came. We can, for example, also hope that web components at some point of time, the developers of Node.js, yeah, for example, they provide server-side rendering, which is also a big problem at the moment with web components. But with iframes, it's not going to work. Yeah, you always need to. The browser always can render an iframe. Also, most of the crawlers and engines, they also know how to handle iframes. Yeah, but they will not know how to handle web components at the moment. So
Yeah.
this is also why some companies maybe stick to the iframe. Yeah.
Yeah, absolutely. This was a very good comment about the trade-offs of iframes and how web components might. Yeah, this is just people listening to us afterwards. How web components might take us a step further in solving some of those problems. Okay. I just wanted to, in the end, I just wanted to mention a couple of companies which do use a similar approach. Just like you said, your company is also using a similar approach. Spotify is the flagship company among those, but there's also a European company called Zalando, which have been approaching the thing in a bit of a different way, building the microservices sort of on the back end and serving them to the front end in a server-rendered page. Then there's also Studio V12, where I used to work before joining Listable. We actually had a pretty big and nicely, I don't know, with very nice interactions. A very low-level style guide with CSS classes and some custom elements, which even though the tech was very low level, allowed for nice interactions on the page, regardless of the technology that other teams were using. And at Listable, I mentioned this already. We're slowly shifting to this approach. And if you keep an eye on my Twitter, I will surely be posting updates about this stuff. So if it doesn't work out as well as we think it will, I will surely let you guys know, so we can draw conclusions from that. By the way, Listable is hiring, so if anyone is looking for a job, we'd be super excited to see you guys in our team. Just one more comment in the end. Basically, web components have been in a sort of anti-hype recently, but I'm pretty sure we're at this point where people expected loads of stuff of web components, that they would solve all of their problems, and they saw that they did not solve all of their problems. As you pointed out, they solved some of the problems but introduced new problems. Yeah, but
this is a well-known hype cycle, the Gartner hype cycle, where after this throw of disillusionment, you can actually find out slowly and steadily that this is an amazing technology, just geared towards a very specific use case, and not solving all of the problems the world has. So it's now up to you and us to find out what's next. And I'd love some more questions if you have some more questions.
It's not a doubt, but maybe a thought that don't you think that web components are going to become some replacement for actually virtual DOM maybe? Because Angular will die, React will, I don't know, 3, Vue, I don't know, 10, but we will still stick to those nice APIs because those APIs are quite usable, nice and friendly. And I can't say the same about Web Components API.
Yeah, absolutely. That's a very, very good question. I also don't think Web Components will replace React, just as it was in this little game with scratching an itch with your nails and with your nose. They're just not made for this stuff. The API of React is way nicer. It's way more declarative than Web Components. I can show you guys. If I just mount this mic here, I can show you one of those components I built for this app was in pure JavaScript with no libraries, no frameworks, no build step even in the middle, and it's pretty ugly. So it's the inline input. Yeah, it's just a JavaScript file. Let's find the item here. Yeah, so basically, this is something super simple for just allowing us to use what's it called, content editable elements, just as you use an input. And it turned out to be a big blob of spaghetti code because the API is just so horrible. So this is one of those trade-offs that you need to count with. I think what's much more promising is the ability to wrap components written in different technologies, in React, in Elm, in Angular, in, I don't know, Vue.js, and deliver them to people under a declarative API of a web component, yeah? In a similar way in which the whole app works. Actually, I can show you one more thing if you're not, if you bear with me. I can show you what it looks like to wrap up an Elm app in a web component. So this is the code that wraps an Elm app in a web component. Elm has a very nice API for dealing with this kind of stuff, with values flowing into the program and out of the program, because an Elm program is basically just a series of pipes which do nothing but just flow values through and output new stuff from some other input. So we've got this concept of ports, which fits amazingly well with the concept of events and incoming props. So all we needed to wire up our comparably complex Elm application to the outer world is these 30 lines of pretty straightforward frameworkless code. Are there any more questions? We had pretty, yeah.
So, that option where you glue all web components. So like, I don't remember at the moment the exact, browser support of web components. Probably I would check on, can I use the code? But like, do you load kind of polish or I don't know, maybe use Polymer or just letting support custom elements in different or other parts of the component specification. Legacy browsers, let's say.
great question. The question was about browser support, what I use to enable this kind of stuff. This app has been made so you can check it out with Internet Explorer, I think 11, and all of those other browsers which don't support web components natively. And basically, web components are a cluster of 4 different standards. Some of those standards are very easy to polyfill with a very lightweight shim. Some of those standards are impossible to polyfill in a consistent way. But the heart of the web component standard is custom elements. Basically, that's the only thing that I use to stitch together those different parts of the apps. And custom elements have a number of different polyfills you can choose from. One of them comes from the Polymer team, but there's another one smaller than that, which you can use as an alternative. They all weigh like, I don't know, 2-3 kilobytes, and you can use it straight away. It's been tested out in production for a long time. Cool. Thanks a lot, guys. You've been an amazing audience. One more closing thing. If you like the talk, you can sort of get back to me by reading through my talk proposal, which I'd like to give on Europe in June this year. And if you like the proposal, you can just star it so as to well, just so I can see if people are interested in that stuff. Thanks a lot.